How you doing?
Good, good.
Nice to meet
Nice
you.
to chat with you. Yeah, likewise.
Which one of your many offices are you in right now?
This is the home office,
Oh, okay.
which is why it's blurred. There's some baby stuff boxes in the background.
Oh, yeah, I know how that is. Thanks for taking the time. I really appreciate it.
Yeah, likewise. I mean, this should be fun. Does this look okay for background?
Yeah, looks good. It's
Yeah.
funny. That actually doesn't even look like a real background
Until you see my bike in the
until you
background.
see the bike. Yeah,
Yeah.
but like the plant and the couch, they don't look real.
Really? Oh, that's funny. Okay.
Well, welcome, Dr. Emeka Anyanwu. Emeka is a cardiologist, a clinical informaticist, and a web developer who's building digital tools for healthcare. He's currently Assistant Chief Health Information Officer at Penn Medicine, the Associate Principal Clinician Engineer at the Center for Healthcare Transformation and Innovation at Penn Medicine, the Director of the Center for Cardiovascular Informatics, and an Assistant Professor of Cardiovascular Medicine at the University of Pennsylvania. Emeka, thanks for joining us.
Yeah, my pleasure. Happy to meet you.
I think I know what a cardiologist is, and I definitely know what a web developer is. What's a clinical informaticist?
Yeah, so clinical informatics, it's actually a little bit amorphous, but I think the best way to describe it is it's a medical specialty. So just like I'm a cardiologist, you can be board certified in clinical informatics, and it's the specialty of medicine that is focused on a couple things. One is, generally the structure and transfer and safekeeping of digital data that pertains to healthcare. And so clinical informaticists can kind of be more academically oriented and be thinking about, hey, how can we use this genetic data or clinical metadata to, digitally phenotype patients and, develop algorithms that can do early detection, disease diagnosis, et cetera. And then there's others that are, I think I probably fit more into this category or thinking more on the applied side, right? And so there's all these different technologies, whether those are vendor supplied or we want to apply technology developed by researchers. And we have to think about how we kind of interface those with existing systems, how we design workflows that aren't terrible, thinking about the human computer interaction,
Mm.
all of those things. And so it's a very, very broad field in that basically one clinical informaticist self-description could be very different from another's.
So you obviously have a lot of jobs. I went through, I think most of them, but you probably have some others that I missed. Can we walk through each of the roles and you can kind of describe what each role entails?
Sure. Yeah, yeah, yeah.
So let's start with your role as Assistant Chief Health Information Officer at Penn Medicine. What is that?
Yeah. So, getting back to the clinical informatics piece and kind of, describing myself more on the applied side, my role as an assistant CHIO. And, for those not familiar with the title, maybe you've also heard of CMIO, Chief Medical Information Officer. And, the transition from medical to health is just, focusing on less medicalized parts of our health. But the general role is supporting clinicians, interfacing between clinicians and our corporate information technology partners, helping kind of translate clinical needs and pain points and difficulties with workflows into technology solutions or things that we need to communicate to our supplying software vendors. Um, and so that's part of the role. I think my particular focus as an ACHIO also really connects pretty tightly with my other roles, and tends to really have a strong interest in kind of custom solutions and internally developed solutions.
So, what is the Center for Healthcare Transformation and Innovation? What are your responsibilities there?
So CHTI is a collection of people led by my boss, Dr. Rita Merchant, who's really been an awesome mentor. And basically, it is a team of academics and faculty, designers, project managers, and change managers and engineers. And we have several different kind of like mini groups within them. But generally, our work serves the interests of the health system and the health system's patients and physicians and other workers. And so we do, in my role, we focus on a lot of custom software development. And so sometimes we are building solutions like around, when the pandemic hit, there were a lot of custom solutions to try and improve communication of issues. We're doing the kind of the red pass thing that a lot of health systems are doing. Do you have COVID? What are your symptoms? Rapid testing. We do some work around supporting, research initiatives and making sure we can get patients where they need to be. And then other things still are just around, cost savings and efficiency for both the health system and patients. You're probably not surprised to hear there are a lot of inefficiencies in healthcare. And sometimes you're in a much better position to address those inefficiencies if you've got your own engineering designers and project managers internally, versus going out on the market and looking for a more generic solution. Sometimes we build things or come up with things that we like and we say, hey, you know what, this is a great solution. Now let's find the vendor that fits what we built the most closely, or at least one that's willing to kind of reshape what they have to mirror what we've done, because we don't want to support that forever and we want to go on and build the next thing.
Right.
But sometimes, we build things that are just enduring parts of the health system and really solve problems for people, which is a lot of fun.
So we'll get into this a bit more later, but how do you learn about these inefficiencies and these pain points? Like, how do they come to you? I know you have your own ideas and you probably see certain inefficiencies, but you're not aware of every inefficiency within the health system. How does that information make its way to you?
I'm not. And so there's a couple thoughts here. I think recently I've really, really appreciated the value of being embedded in clinical care. And so there are days where I'm super tempted to just be at the keyboard nonstop. Um, but then, when I step away and I'm seeing patients or working in the echo lab or rounding in the hospital, I'm like, oh, this is really good because I'm seeing all these little problems.
Right.
And you probably, like me, as being familiar with software, you like instantly can recognize, like, wait, why does this have to be done manually? Or why are there 10 steps in 3 different applications instead of, one way that transmits them all? And so I think one key part of it is just kind of having that shared experience of the clinician and the hospital employee that's trying to do good for their patients,
Right.
and then experiencing where things just kind of suck.
Yeah.
And then I think recognizing that you just have one experience. And so I'm a cardiologist, but what does the gynecologist feel?
Right.
What does the family doc feel? And so I think the truth is, and I think this is something that's really exciting about Penn and other health systems like it, is that we are either trying to find and support.
Complete.
Yeah. We're either trying to find and support more people like me or grow them internally, right? Because I think the more people you have with like an engineering or problem solving mindset that are deployed around, they will also find kind of pain points or issues that they think they might be able to solve.
Tell me about your work at the Center for Cardiovascular Informatics, where you serve as director.
Yeah, so I think that's the easiest one to describe, because that's like the last 2 things we talked about with a cardiology lens, right? And so I am a clinical informaticist, and so I interface with IS and information services, and we talk about things like how our EHR is working, how our PACS system, that's the system where we review medical images, is working and interfaces with the EHR. And I've talked a little bit about CHDI and how we build custom solutions. And so often some of the first places I come up with ideas are in cardiology. And so wouldn't it be great if we had kind of a little internal service center or lab that my cardiology colleagues could come to and say, hey, I'm trying to do this research project, or I'm trying to accelerate this clinical trial. Can you help me get this data or work with this outside vendor? And so that's what the Center for Cardiovascular Informatics does, is kind of being like a local small touch point for anybody in cardiology interacting with data.
Interesting. So it's funny, as I was going through and creating these questions, I was split between, I want to learn more about cardiology, but I also want to learn about the tools that you're building for healthcare generally. So I have questions about cardiology specifically, and then others that are probably completely
however you want to go. Yeah. There's probably a lot of overlap between the two, to be honest.
Yeah.
The one thing I'll say about cardiology that I think has been really helpful from my perspective is that cardiology is kind of everywhere in a health system, right? You've heard kind of the saying that, heart disease is like, the number one killer, top three or
Right.
whatever. We tend to focus a lot on cancer because it can be really surprising when it shows up. But heart disease is just everywhere, and that means that we see a lot of patients all the time, and so there's a lot of throughput, and that just means there's a lot of opportunities for improving our workflow and technology.
So you specialize in non-invasive cardiology. What does that mean?
Yeah, and that's a little bit getting in the weeds of clinical practice, but the idea is that cardiology is really exciting because there are invasive methods,
Mhm.
and so people that um, interventional cardiologists, electrophysiologists, for example, that will do things like cardiac catheterizations, pacemaker implantations, ablations,
All right.
and in cardiology, many of these things are minimally invasive, meaning that they're usually done through the blood vessels in the body and the wrist and the groin,
Mhm.
as opposed to opening the chest.
Right.
So a non-invasive cardiologist is kind of the opposite. I treat people medically, but I generally don't do procedures,
Mhm.
with one exception being transesophageal echocardiograms, which are kind of like an endoscopy with
Oh.
an ultrasound attached that looks behind the heart. But even that is far less invasive than my colleagues who do other procedures.
Let's talk about building tools for healthcare.
Yeah.
What types of products and tools are you building for healthcare at Penn Medicine currently?
Yeah. So I think on my plate right now are two main projects. One is way more mature, the other is very early on in an experiment. The one that is more mature isn't that sexy, but just has such a strong business case. And I think is probably my favorite right now in some ways. And that is digital fax processing. And so, as a health system, Penn Medicine and probably all of its peers are receiving on the order of 10,000 digital faxes per day. And many of these faxes are transactional. Walgreens, CVS, if they can't interface the information they'd like indirectly, they'll say, "Hey, Brandon has a refill for his blood pressure medication. Can you please send in a refill?" And they'll keep sending that fax at 2 a.m. every day until
Mhm.
me or one of my colleagues fulfills it. And
Right.
then there's other cases where you go see a doctor and they fax over your old records because you're going to be new at Penn.
Okay.
Um, so high volume, but the issue is that previously all those 10,000 per day faxes were reviewed and triaged manually. And so somebody would open the PDF that comes in from our digital fax server
Mhm.
and say, okay, oh, this belongs to Brandon. Now let me make sure I find him in the EHR by his name and birth date, because that outside place probably doesn't have your internal medical record number, right?
Right.
And let me know, find out what the document is, and let me send it into the EHR. And so we built an internal system that links all those pieces together so people can process all that in a single application that's web-based. And then we've layered on top different algorithms that do things like patient detection, document type detection, spam detection, duplicate detection on top of it all.
So what is the idea? It links, for example, an incoming fax to a patient's record?
Yes, with a human in the middle. And so previously that like getting that digital fax into the medical record and alerting the clinical team would take like 2 minutes, 2 to 3 minutes per document that
Mhm.
were done manually by a person. And so with this system, it's kind of like sitting in front of your Gmail inbox and you would open one of the faxes in the inbox and many of the metadata are now pre-populated by those algorithms I talked about. And
Okay.
so you would open a fax and say, hey, this looks like Brandon. It looks like Brandon has a refill. This is the doctor it belongs to you. Do you agree? If so, great. Click confirm, and then we'll just send it to the EHR. Previously, that was all manually
Wow.
done, and you would have to use like two or three different applications.
Okay. How did you identify this problem, for example? Like this was maybe this was a known issue, right? Everyone talked about this.
Everybody generally hated it.
Yeah.
When we started, it didn't feel like there were many off-the-shelf solutions, and they are coming, but I wouldn't say they're commonly used even at this point. And so, getting back to my early point, is just through suffering through it, right? I was seeing
Yeah.
patients. They were telling me that they were having stuff faxed in, and I was like, I don't see it. I think you're lying. I'm just kidding.
Yeah.
But I just couldn't find it in the EHR. And so then I started to investigate, how are these documents coming in, and found a very, very manual and varying process throughout the enterprise that involved, a couple different technologies that if we think probably in similar ways, you look at all these things as like, oh, the fax is already digital.
Right.
And, the way we get it into the EHR is digital. These things can all be connected together. This is an interfacing problem. And
Right.
so that's how it started. And then once you interface these things, the next thought is like, well, can we automate these steps? And yeah.
Okay. This is a great project. Can you walk me through the development process? You identified the pain point.
Yeah.
You knew the process. Maybe you had to learn more about the current manual process. What was your development process? Like, how did you develop a solution to this problem? And what technology did you use?
Yeah, yeah, yeah. So this is a pretty fun one. This is actually, like I said, my favorite because it's kind of got all my key ingredients,
Yeah.
and those key ingredients have evolved over time. But when we started, it was me and another developer within CHDI, Gideon Whitehead, and he had already had kind of like a small web app he had generally built for the idea of medical records processing. And basically, we stood that up on a VM that lives on our private cloud in Azure.
Mhm.
And our first step was to say, okay, can we get these faxes? The way the faxes were being delivered was through a shared Outlook in basket. And so we had to use, I think we used Microsoft Graph API at the time. Basically, had to go through governance to get access to the inbox. But once we did, we were like, okay, great. New email comes into this specific address. We'll just, pull that down to our server. We'll store that on, basically a blob store. Then we built like a PDF viewer around it. And then, funny enough, the initial workflow had involved Outlook in Basket and shared drive, shared network drive, right?
Okay.
So somebody would open the document, review it, and then put it on the network drive and rename the file to Brandon's like refill.
Oh, wow.
And so our initial, yeah, there's lots of problems with this that you
Yeah.
can imagine, including accidentally copying the entire folder to another one if you've done that by accident in Windows.
I'm sure. Yeah, I'm sure no mistakes were made.
Yeah, that's not at all. And so our first step was like, can we pull the faxes? Great, we can do that. And the second step was like, well, let's just replace a portion of the mail workflow. So we actually mounted the network drive to our VM and we just write the file renamed. You would kind of like look up the patient's name and we would rename the file for you. And that was like a little bit of time savings. And then another team down the hall was still doing their manual thing of dragging from that network drive and uploading to the EHR.
Okay.
And so we built that thing and we built it actually in my practice. And that kind of gets back to the being embedded. And so I talked to my nurse and my admin assistant and said, hey, I built this thing. Can we try it for a couple of my patients? Just do it on me because, I think it works, but let's be cautious here. And it worked. And it actually was helpful enough that the AA, after having used it for about a day, actually just started training her colleagues to do it for other doctors.
Mhm.
And to me, that was kind of the first clue, having built a couple other things that like had legs, but didn't have all the, we talk about product market fit, right?
Yeah.
They were hard to convince people to use. Here was something we built that people were asking to use and kind of just naturally disseminating. So that was really exciting. And so that's how we got to our proof of concept. And I can walk through kind of all the subsequent steps technically, but it's basically a VM with a network drive and Graph API.
But what's the part of the process that
Mhm.
identifies which patient the fax is for?
A human being's eyeballs, at least initially. So the
Right.
manual flow, yes, was a human being's eyeballs, and then they were opening up the EHR to search those names. Now, the part we eventually built, actually pretty quickly, Gideon built this part. He basically, let me see. So the fax number, right? Penn probably has 1,000 fax numbers, and many of them are scoped to a department.
Oh,
Penn has millions of patients,
right.
but in each department is a fraction of those. And so we knew the fax number for my department. And so then we could basically take a slice of the available patient identifiers from the EHR master index and kind of sync those to the application database. And so then we OCR'd the document, getting built like a rudimentary, let me see, named entity recognition. And these are terms that I learned when we were working together.
Right.
Us to basically detect probable names. So Brandon Krukowski, right? That looks like a name. oh, and this looks like a birth date. Now let me search the index of those patients that
Right.
we've retrieved from the index from the EHR. And when we find a hit that looks pretty solid, we tune for high specificity, right? We wanted to be like 99.99% sure. And if we weren't, we would just leave it blank because you could
Right.
always do a manual search. And so then we would pre-populate that information. When you pre-populate that information, it comes with basically the IDs that are needed. Well, at a later time, we did direct interfacing. And so then the document could be directly interfaced through HL7 to the HR using the identifiers that we would also kind of store in the background. So that's kind of a little bit more of the
Okay.
technical. Yeah.
Interesting. It
Yeah.
doesn't sound like the individual steps are that complicated, but like
No.
what impactful use case overall.
Yeah. Yeah. That's the fun part, right? It's
Yeah.
like elegant in stitching all these. Yeah. I love systems that have a
Yeah.
lot of tentacles. And this one had a lot of tentacles, right?
Right.
And it was also like asynchronous, which was fun. Like we're pulling these things, we're batching them. We've got like, we're using Celery and Flask. And so we've got a bunch of Celery tasks that go through each thing. And yeah, it was nice. It's fun.
How long did the entire development process take?
The proof of concept was done in weeks, like, I would say 3 to 6 weeks. We were piloting within my clinic with my patients.
Yeah.
Um, the product matured over probably about a year and a half for a number of different reasons, which I'm happy to kind of share. But, the version we started with is very, very different in look and feel and functionality than what we do now.
And you've always had the human in the mix, right? So like the final step is really review this information. This is who we think the patient is. Would
Yeah.
you like to move forward?
Yeah. Yeah. Yeah.
What did your testing look like? Did you have any automated testing or anything like that? Or did you just have people using the system repeatedly and like confirming whether or not the summarized information was correct?
Yeah. So, on the like actual infrastructure side, there are some integration tests, right?
Okay.
For the actual like software stack. But I think what you're talking about is really more like the algorithm, right? And so we have the nice thing about this kind of problem is just by doing the work, users continue to generate your ground truth, at least if they're paying
Right.
attention. And these are people that are generally, paying close attention to make sure that they don't put Brandon Krukowski's file into Mecca's file, right? And
Right.
so we are always, treating their work as the ground truth. And then meanwhile, we are kind of saving our, initial inference. And over time, we've done at various points, we've compared what the diff is.
Okay.
And as I said, we've tried to tune for highest specificity at loss of sensitivity, right? And so we, as the product matured, we kept kind of going back and saying, hey, is there a lot of mismatch between what we're suggesting, what people are doing or not?
Did you have an organized way of getting feedback from the users of the system?
Initially, no. Initially, it was just like,
Yeah.
hey, let's do this thing. And, my office is here, my door is open, and I'm going to bring it up, every like 2 weeks at our weekly meeting. And the nurses know where to find me to mention
Right.
the issues. And that works for like one clinic, right?
Hmm.
Scaled to another clinic. And then this is a clinic that I've actually never been to, at least yet, across town. And we would have regular meetings with them, kind of as a check in. But
Okay.
it was still direct feedback.
Right.
We've since kind of brought on product managers for scaling. We have a ticketing system that
Oh,
is incorporated in the enterprise ticketing system, et cetera.
you're also the founder of Mobile Health, where
Yeah.
you built moblMD. What is that?
Yeah. So moblMD, this is another one of those um, simple simple solutions for a common pain point. And the pain point is, as a medical resident, I was running around the hospital getting pages on a pager.
Hmm.
Um, and when I get those pages, I would dial them from my cell phone, and the pages would come in with 5 digits, and I would have to remember which one of the hospital's 5 or 6 dialing prefixes.
Oh,
So this is in Chicago, so it was 773-926, whatever
okay.
from Chicago, and I would have to like match the page to the right prefix, and probably not know who the person I'm calling is, and call them from my cell phone if I didn't want to have to go to a landline. And so moblMD was simply a centralized repository for those numbers
Oh,
that
okay.
you can use to return pages and also look up numbers. Um, it became kind of popular, and then it really surged in popularity when the pandemic hit,
Mhm.
and there was kind of this forced distribution and asynchronicity to how we were doing clinical care. And so we weren't rounding in a group of 5 to 10 people around the hospital as much anymore. There was a lot of like, let me see the patient, let me call the patient's room, let me call this service. And so, and many people were working from home. So moblMD helped to kind of bridge that gap between um, the information people needed at the point of care and what was available, which was an intranet or PDFs or sticky notes that they were keeping that weren't up to date.
And is this being used within different healthcare organizations? Is that the idea? It's not just
Yeah,
Penn.
yeah.
Okay.
It was developed when I was in residency and fellowship at University of Chicago, and it's still
Okay.
being used there. Yeah.
Could you make these tools available to other healthcare organizations outside of Penn Medicine? For example, the system that you built for receiving faxes, that's
Yeah.
obviously very embedded in Penn Medicine's system. Could that be made available to other healthcare organizations? Let's say they learned about it and they were interested in adopting this type of system. Could you make that available or do you?
I think that's an interesting question from a technical perspective and then also a business case
Yeah.
and support perspective. From a business and support perspective, we would have to, and you're part of the university as well. So we would have to kind of investigate, the IP and how we could license
Right.
this out and the right entity structure and all that. Assuming we can do that, then we would also have to have adequate support. And in working within the health system, I've truly come to appreciate how much it takes to support enterprise software,
Yeah.
both in change management and ticketing. So we would have to do that, which I don't think is impossible. And then technically, another thing I've learned is that you know part of the reason solutions developed internally can be so good is because the data culture and
Yeah.
the infrastructure. And so I have this kind of concept that the more generalizable software becomes, kind of the in some cases the shittier it becomes, or just
Yeah.
the harder to manage it is. And so while we could do it, it would take work.
Yeah.
um, this is all in a landscape where first and third party solutions that solve or are trying to solve the same problem are growing. And so we use Epic. Epic is coming out with their own solution. There's at least one other, probably multiple other vendors
Oh,
I've seen that do this. And so we could probably compete with the vendors, maybe not Epic, which is unfortunate,
right.
but probably with the vendors. But then it's like, that would be my 100%, right? And I'm not going to be able to talk to you about LLMs unless they're LLMs
Right.
focused on faxing, right?
Right.
And so, for those reasons, we haven't. The one caveat is that uh, we are a large distributed health system, and there are actually a couple other sites that aren't part of our main EHR instance. And we're
Oh,
now in stages of talking about, can we port this to their instance? And so technically we're starting to think about how can we refactor this to be multi-tenant, right? We're going to need different service accounts and API keys, et cetera, to
oh,
access this other hospital's data and incorporate it into our health system and then redo identity, et cetera. So that'll be fun. Fortunately, they're kind of like, from an ingredients perspective, they're kind of a mirror image. So while they're separate instances of everything, they're still using Epic, WriteFax, and OnBase as
okay.
kind of the core infrastructure. So it shouldn't be too bad.
And Epic is what? The healthcare record system that's used by all healthcare organizations?
Yeah, I
Okay.
try to avoid mentioning it up until now, but it's hard to help. It's a great and acquired podcast that probably most people have seen recently. But
Yes.
yeah, it's the predominant player. I would estimate probably anywhere from like 40 to like 60% of market share. And when you're talking about large academic health institutions, probably even higher than that.
But is that helpful? In other words, so I go to Penn Medicine for most of my care. Let's say
Mhm.
I'm in another state, I go to another hospital, doctor. If they're using Epic, they should have access to my record. Is that the case?
Yeah, yeah, and that's one of a selling feature
Yeah.
from a clinician and a patient perspective is that they do kind of they have their inbuilt product for information exchange,
Hmm.
and that's kind of getting back to clinical informatics. That's like a core job description for some folks is just working through information exchange.
Yeah.
But if you are essentially the operating system, then basically you can build your own layer that does all of that. Kind of like how now there's RCS for text messaging, right? But
Oh,
before Before that, Google Chat did their own thing and
Right.
iOS did iMessage,
Yeah.
right? iMessage is just uh, way more robust solution
Yeah.
that is always going to version way faster than RCS ever will. But, you know, there are other ways to interface. But yeah, Care Everywhere is what it's called. Does the exchange between Epic systems.
Interesting. I'd like to talk about your career journey a little bit.
Sure.
So you've definitely managed to carve out this incredible kind of hybrid career, cardiologist, informaticist, software developer. Take us back to the beginning. What drew you into medicine? And then how did you get into coding and programming and software engineering?
Yeah. I mean, in true honesty, it was actually the reverse.
Oh,
I had long wanted to be a software engineer. And probably the origin story for that is I I have always loved breaking and fixing things. And I had a close family friend who basically worked for the local cell phone company. Um,
oh,
and he was basically like a systems engineer. Like he did like their mainframes at that time, their Linux Unix stack. Um, and so he taught me how to fix the family computer and then how to fix it when I broke it. And then, when we would catch up over holidays, he would like tell me about things that like just blew my mind. Like I learned what Linux was in probably like, I don't know, maybe sixth grade. And
yeah.
then, BSD. And then I think he got me on Slackware Linux when I was in junior high
Oh,
school. And
wow.
then I met a friend that was into Gen 2. And so like very quickly I was like, well, how do I start a web server? How do I, create my own version of the network drive that I see in my junior high school
Okay.
network? And so I got into that stuff. And I also got into web development, kind of actually more on the design side.
Okay.
Um, More like there was this form called Yaxane, there was DeviantArt. And so this was back in the like Dreamweaver and front page kind of era
Oh, yeah.
where you would use Photoshop to like
Yeah.
design this layout that was pixel perfect, and then you would
Yeah.
slice it up
Yeah.
and translate it into HTML and CSS.
Yeah.
And so I did all of that. And so I started to like design, but then I was always like, well, there's this like, I would like to like tear apart other people's websites and be like, there's something different. Like there's something dynamic that I'm not seeing in the source code. And that's when I started getting to PHP and
Okay.
eventually, other back-end web development. And that's where I really settled as in, web software development as opposed to the design.
So where does medicine come in?
Yeah, yeah, yeah.
So was
Sorry.
medicine your backup?
So here's the thing. I grew up in Canada. I'm first generation Nigerian Canadian. And maybe many can relate that the immigrant experiences, hey, you've got to find a really solid career footing that's going to support you and your family and is going to really kind of um, is going to really allow you to benefit from meritocracy, right?
Okay.
Um, and by that I mean there are all kinds of physicians and clinicians and other people in the medical field that haven't been in this country very long, but their skill set and their clinical expertise is super valued and well paid. And so my family kind of felt like medicine would be that for me. And kind of at the time, I think it was probably also in the .com kind of rise and fall. It was like, look what just happened, all these internet people. You don't want to
Oh,
be one of them.
got it.
Go into the secure career. You can do this like computer toy thing on
Yeah.
the side. There are all these like, 1-800 computer technology courses that you would see like on the television. And they were feeling that it was really commoditized.
Okay.
So I was encouraged to go into medicine, and I happen to like a lot of the kind of core requirements like physics and bio.
Okay.
And so that's how I got into medicine. But my true core love was really the engineering.
Interesting. And then why cardiology specifically?
Mm. Because for me, that was the most intuitive application of engineering kind of concepts.
Oh,
So I was in medical school. We were in the cardiac intensive care unit, and it was just this beautiful kind of like, hey, let's look at the EKG for this patient who just, came in with a heart attack. Oh, we can see the ST elevations and the change in the voltage on the EKG. Well, now let's look at imaging and we can see that, this front portion of the heart isn't squeezing as well. That correlates with the EKG. And then, oh, now they have heart failure. Their heart isn't, making as much output. And so let's think about how their output relates to their vascular resistance. And then like somebody walked me through that and I was like, that's Ohm's law. That's like current, resistance, and impedance, right? Or like current, flow. No, hold on, let me get this right. Voltage, flow, and resistance, right?
Okay.
And spoke like a cardiologist, that would be cardiac output, SVR, systemic vascular resistance, and
I'm
equals
going to take your
I.
word for it.
Yeah. Let's anyway, it was just this beautiful way to apply the sciences that I love, like physics, within medicine.
So did your background in engineering, technology
Yeah.
help you in being a cardiologist, would you say?
Um, I mean, to the extent that like the parts of physics that I liked, I just like thinking about like EKGs, maybe a little bit.
Yeah.
Um, Thinking about balloon pumps and mechanical circulatory support, but
Okay.
maybe not directly. Yeah, especially not the software stuff, I don't think.
What's the first problem you tried to solve within healthcare with
Ah,
technology?
okay, I'm glad you specified healthcare because I tried to solve a lot of
Yeah.
things that weren't problems; they were
Because I'm sure when
solutions.
it sounds like when you were 6 years old, you were trying to solve
Yeah,
a problem.
yeah, yeah. We really need like a domain server in this. That's yeah, no. And so when I was in medical school, a couple different things. Like I think one was we had a traveling clinic, and we went to Peru, and we needed a way to kind of log some of our visits, and so I deployed this like mobile EHR, open source EHR, which is called OpenMRS. It's still around.
Hmm.
And so the way I deployed it was on a MacBook strapped to a mobile, like a consumer router that was flashed with OpenWRT. So basically, I had a hotspot and a laptop, and everybody else had hotspots, and they
Okay.
would connect and log in and log the patients they were seeing and diagnoses and
Oh,
medications administered.
wow.
So that was kind of like a cool application of my background in web software and some networking, et cetera, and some
Yeah.
DIY.
In your time at Penn Medicine and beyond, how has your
Yeah.
approach to building for healthcare evolved, technically and philosophically?
Yeah. So I think philosophically, and just recognizing that there are more problems than there are problems with sound business case. And by business
Oh,
case, I mean like it's a big enough problem and a big enough a problem that affects the financials or kind of burden somewhere that a health system should either resource internally to solve it or pay somebody else to solve it as a vendor. Um, as a software minded person in healthcare, every day I stumble into things and I'm just like, yep, that's a problem. Not big enough.
right.
Yep, that's a problem. There's other problems that we got to prioritize. And so
Right.
I think that's one thing that's adapted for me over time is trying to kind of ground the things that I want to address in something that matters to everybody, both the people managing our finances as well as the clinicians and the patients.
I'd like to talk about AI a little bit.
Yeah.
So obviously a lot of hype around AI in healthcare. How is AI currently being used in cardiology?
Yeah. So I think if we're talking about cardiology specific,
Yeah.
we're now in an era where disease diagnosis or at least suggestion, right? Human in the middle still. And
Mhm.
I think it'll be a long time before we get away from that. Is very, very practical.
Mm.
And so I had worked last year with a researcher who spun out a startup that was looking to do basically disease diagnosis based on echocardiograms, which are moving ultrasound images of the heart. And so he developed kind of an image model that would take DICOMs and run them through a pipeline. And then at the end, he would spit out a probability.
Mm.
And so that's a thing that you can do now. Sticking with the theme of like medical imaging, we do a lot of measuring in cardiology, measuring your aorta, measuring your valves, measuring the velocity blood moves in your heart. And typically that's done manually and measured by a sonographer or a cardiologist, kind of like point and drag. You can imagine doing that 30, 40 times in a study.
Yeah.
And so there are now kind of off-the-shelf software that you can interface into your PAC system that'll do that for you. And it'll read a full echo from end to end and say, we group these images together because these, fit this part of the protocol, and we made all these measurements. And oh, hey, we'll even flag the ones that look abnormal. So that's something that is definitely kind of prime time in cardiology now, at least prime time in terms of like actively being deployed. I wouldn't say it's everywhere, but it's definitely in places. And I think every echo lab is aspiring to do something like that at this point.
Is Penn Medicine doing this? So like disease or diagnosis suggestions or this measurement, like is it actually being used at Penn Medicine?
Yeah, so I will say that disease diagnosis algorithm, basically, we were doing external validation for a company that was pursuing software as a medical device kind of certification.
Yeah.
And so that was like a non-prime time application. Like it was true images that we were IRB approved to use, but it wasn't in the actual path of care. Now, in terms of actual kind of measurements and that kind of stuff, I actually think I just saw an email that one of our PAC systems is being upgraded soon to do automatic ejection fraction detection. And actually, our ultrasound carts already do that.
Okay.
Ejection fraction is basically how efficiently your heart squeezes. And so that's another thing you measure manually twice and then calculate the difference. Now the computer can do that automatically and suggest to you a percentage. And so I would say, yes, we are online with stuff like that and looking to move forward.
That's cool.
Yeah.
Very cool. So let's talk a little bit about LLMs. So you recently posted about building LLM tools with non-agentic flow.
Yeah.
So first of all, what is the product that you're working on? And also, why are you kind of leaning away from the popular agentic style of development?
Yeah. So the product we're building is I guess you could call it a chat application, but that's actually the exact premise that I'm leaning away from. But it's basically imagine you have your EHR Epic and an iframe to use web speak, like an embedded web application. You basically have ChatGPT on the side. That's what we're building, right? And so very quickly you can, maybe copy in blurbs or diagnoses from a patient's chart and say, write a medical excuse letter to Brandon's employer that says he was seen here today and this is what he was seen here for. Taking that a step further, what we're looking to do is develop pre-scripted flows. And I think one of the most promising and probably it just seems like a good fit is summarization, right? So Brandon's been with us for 5 to 10 years. He's seen X doctors in cardiology and had 5 different procedures. Can you, LLM, generate for me kind of like a pre-visit checklist of the things that a cardiologist would want to know? What was his last imaging study? What meds is he on? What does his blood pressure look like? What surgeries has he had? And so that's what we're building. And kind of what I talked about in that blog post about agentic versus non-agentic, I take agentic to mean that kind of the flow control of the prompting is decided by the LLM. And, this is probably a little bit to be, transparent. This is just me learning the field and in a field that is rapidly moving. But for me, I'm a clinician. I know exactly the 8 places I would look in before every visit to gather, useful information, both scanned documents and PDFs, as well as discrete data. I don't want to trust an LLM to look through all those things in a way that's non-deterministic, right? And for me, I think one of the most elegant ways to apply machine learning and AI is in using very small, tailored models for very specific purposes, and then chaining them all together, right? And so the approach I'm taking is, hey, LLM, I don't want you to just, decide what is important to a cardiologist and decide which pieces in each part are important and extract them. No, instead, I'm going to tell you that, hey, you should look for studies that match this description. And within these studies, da 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 da. And then at the end, these are parts of the studies that a cardiologist is most likely to find valuable. And then make sure they conform to this standard format. Because I've learned that there's actually a lot of cognitive fatigue or stress, if you will, in trying to process the same information, but in various formats over and over. And so clinicians want to see stuff in a standard format. And that's why every medical report looks the same if it's coming from the same institution. And so that's why I'm kind of getting away
I
from the
see.
agentic kind of thing, because I want to just prescript everything.
Right.
And I mentioned I'm not really into the chat thing because I also feel like clinicians, at least those that aren't really just trying to play around with an LLM, don't want to go back and forth and wait, actually no, clarify, actually no, rewrite this part. I think they just want something that they can click, and
Yeah.
maybe they'll wait a minute, 2 minutes, and it'll give them something useful that is in a format that they expect. That's kind of my hypothesis that I'm working on.
I see. So you really want to have more control. It's a more structured flow to the application. Because the way I view it,
Yeah.
AI agents
Mhm.
basically just another way to develop the flow for an application. It's really just multi steps, right?
Yeah.
Some of
Yeah.
them might use an LLM, some of them might not. Like you could just have
Yeah.
agents that do other things, right? They query a database uh,
Yeah.
or pull information from some other data source. It just sounds like you've structured the application in a different way, and you've decided to not use the agent based
Yeah.
approach.
In some ways, you could say that this is just natural language processing on steroids for us, right?
Right.
It's just way easier, right? NLPs have been around for a long time, but now it's just like it's super easy that anybody can do it. And I just want to use the NLP component to say, extract information that has this semantic meaning and then follow this flow. Don't even decide what APIs to call. I'm going to do that for you.
Right.
And
Right.
I've kind of got this idea of progressive abstraction. Once we get that first part to work well, then maybe the second step is, okay, can we generalize these calls to be useful for different types of clinicians? And then,
Oh,
maybe some of those parameters are then decided by an LLM, et cetera, or customized by the clinician themselves.
oh,
But to
I see.
start off, I want to have all the control.
So the LLM that you're using in this
Yeah.
chat app, this is a what?
Yeah.
Specialized trained LLM to be able to handle patient data and then summarize it and make recommendations for the next step in the process for writing an email or whatever it is.
No, I mean, actually, right now we're playing around with off-the-shelf ChatGPT.
Oh, it is. Okay.
We, yeah, 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 yeah. I
Oh,
mean, you know, well, first of all, I think at this point, consumer LLMs definitely have been trained on medical data.
right,
Not to the point where you would want making your diagnoses, but they know what aortic stent. Well, saying they know what it means is a little tricky, right?
right.
But they have the right semantics for aortic stenosis and cardiovascular disease, such that they can make meaningful translations and extractions from medical documentation, especially when very well scoped. And
Oh,
so ChatGPT serves, so far serving that well. The one thing I will say is that there's a little bit of inherent risk in using ChatGPT because it's not version fixed. And while we have kind of a BAA with the Azure flavor of ChatGPT, we still, I think, if this becomes an enduring product, would want a model that we can version lock, and I think that would help it become a little bit more deterministic, or at least a little bit more stable in its output over time,
okay.
right? I don't want to encounter the same problem I do with my Google Home, where 3 years ago I would tell it to listen to the radio and it would work perfectly. Now it plays some random YouTube video. Like, I don't want that kind of like performance drift over time.
Yeah, especially when you're dealing with patient data. It's funny,
Yeah,
ChatGPT does it again, right? It's so like multi-purpose that it can handle,
yeah,
like you said, it's been trained on a lot of medical data, but also all kinds of data, like
yeah,
all data everywhere.
yeah, exactly, right. Like, you know, 1,000 cardiologists have been in YouTube videos talking about cardiovascular disease. If the
Right.
rumors are true, that training data has found its way into many LLMs, right? And so, yeah, there's just tons of info out there that makes them useful.
And this chat app is being used now.
Yeah, it's being used by a very small scoped kind of set of users, and I think that kind of follows our tradition of like expanded rollouts. So just like with the fax thing, we're starting with a small set of users, and in this, we're starting with a set of users that are focused on a specific use case, right? And so there will be some people that just get in there and play around, but we want mostly some validation that people that are using it. I think I blogged about breast oncology. People using it for breast oncology are finding its output helpful for that purpose.
Wow.
So we know how to kind of modify the flow and interface, et cetera.
It's another real like great use case, right? Because a lot of people are putting stuff into ChatGPT, having it summarized, and then you're copying and pasting it into some other tool anyways, right? Like an email.
Yeah, yeah, exactly. And so that's exactly why we want to be careful, right?
Yeah.
It's feasible that at some point we might get to a point where we would encourage people, or at least, not be worried that they would copy and paste the output into the medical chart. But in these early stages, we want to be very cautious about, being able to trust the people we're working with to like, hey, you got to be really scrutinous of what this thing is doing
Right.
as we kind of develop more and more confidence in it.
So how do you balance everything? You have a lot of jobs. You
Yeah.
have leadership positions, you're a professor, you're a practicing clinician. How do you actually balance everything?
Yeah, I've thought about this one a little bit before, and I think one of the things is that um, I'm in an environment where people are really encouraged, and probably your environment on the university side as well. People are really encouraged to go kind of very deep um,
Right.
in their, focus or special clinical specialty, et
Mhm.
cetera. And so I like to joke that there's a cardiologist that will treat the left superior pulmonary vein, like this 1 out of 4 parts of the heart on a Wednesday for a
Right.
certain type of patient, right? So to speak, that just they're, I have so many colleagues that are exquisitely specialized, such that, I know exactly who to call for what. And so for me, I think that thing is software and the way it makes our lives better as clinicians and better for patients in the health system. And in doing so, there's a trade-off, right? There are problems that cardiologists that is 100% clinical and only clinical might address that I might say, hey, I could address this problem, but I don't see as many of these. Let me pass this off to this other person because I know that's all they address,
Right.
right? And in fact, they might not even address things that I feel comfortable about. So, an environment where there are scientists doing that, where there are clinicians doing that, and there are informaticists doing that, that's kind of how I feel a little bit more at ease
Oh.
focusing while knowing I'm kind of an environment that supports kind of going super deep.
What advice would you give to young clinicians or engineers who want to work at the intersection of medicine and technology?
Um, so I think I would say, I think one thing I've said before, and I'll say again, I love the software. I love the networking. I love the stack. I love it all.
Hmm.
You don't need any of that. I mean, I think you should have general concepts and you should be fast on some of the key language, but you don't have to go as deep into the software part. A large part of technology, as you know, is people and process,
Hmm.
right? And so, um, maybe you want to be an informaticist and work with technology, and your key specialty is just like rollout, validation, change management. And that is absolutely what you should focus on. And there's plenty of need for that. Maybe you're just like me and you want to be super, deep in the software. And so I
Right.
think to generalize that advice, I would say kind of if you're interested in informatics, come as you are, because we need all of you.
Hmm.
And if you've got the clinical piece, you've got the technology piece, you've got the change management and organizational piece, you will be valued. And we're in an era where everywhere needs people that want to kind of span kind of this domain. So that's the first thing. And then I think for me, I just like, as a technology person, I'm always kind of reading up, trying to figure out what's next,
Hmm.
trying to experiment, trying for trying's sake. Um, and then honestly, looking up for mentorship too. I don't want to be around people who can teach me things that I don't understand, who can kind of push me or disagree with me.
Yeah.
And that's helped me grow immensely. And sometimes I expose myself to those people at no remuneration, or is it? It's without being paid. Let me say it
Right.
that way, right?
Right.
So there are things that I've done for free just because I thought it'd be a good experience. I've learned incredible amounts from that. And so I think, especially people that are starting off, they probably don't have as many commitments to their time. And so I would encourage them to just jump into things, even if they don't necessarily think this is like a unicorn in the making. If there are people you can learn from, or if there's exposure you're going to get from it, it's probably worth it.
What's the biggest problem in healthcare that you'd like to be able to solve with technology?
Hmm. Biggest problem? I guess I'll tell you one thing that annoys me a little bit, uh, which is we are software people. And so you look at a clinical software suite and you're like, yep, okay, this is all relational data. It's all probably stored software and somewhere in a database. And so there's all kinds of ways that this information can be used secondarily. And
Mm.
in that that key kind of application data doesn't make its way in entirely to the HR or other places where it can be used secondarily for research or et cetera. I
Oh.
wish more health systems would kind of engage in this like enterprise data laking kind of philosophy where you just take wholesale all the vendor application systems and copy wholesale read only all their application databases, recognizing that at many times in the future, you will be able to tie those back in ways that are useful, that your interfaces that solve business problems don't incorporate, right? Because when you're interfacing two pieces of clinical technology together, often all you need is the final output of the report.
Right.
But so much richness in this raw data, especially in the era of machine learning. So I'm hopeful that more health systems are going to just saying, hey, vendor, we want this data and we want to own it. I think there's a little bit of enshittification going on where a lot of vendor systems want to perpetually sell you back the data. And
Hmm.
so like
Right.
they'll have like, oh, well, this is our research grade stack. And we sell you the clinical system, but if you want all the data, you gotta, subscribe to this cloud service or this research copy of the server that we're gonna manage for you and charge you an extra subscription. Meanwhile, the core application data is on a Microsoft SQL server that we own and manage on-prem,
Right.
right? So I would love for us to get away from
Yeah.
that.
You ready for the lightning round?
Yeah, hit me.
30 seconds each, unless I have a follow-up question.
Okay.
Favorite coding language for healthcare apps?
TypeScript. And I think a very obvious reason why, other than I like static typing, if you're in healthcare, there are actual fire data typings that I've not seen replicated, at least not in Python, that's as nice. And so it's not perfect, but it really helps if you're trying to like jump through a JSON tree of fire data. And it's part of the at types kind of
Hmm?
giant package of types. Yeah.
Interesting. Clinical tool you wish every hospital had?
Clinical tool. It's not clinical, but getting back to that data lake thing,
Yeah.
I think the tools that solve this are things like Snowflakes, Databricks,
Yeah.
and then for like the open source versions like Apache Spark and that kind of stuff. Yeah.
One epic feature that's underrated or underused?
Oh, easy. I have like a clean desktop philosophy, and so
No.
I don't do shortcuts or anything in the taskbar, and so I always do like Mac key spacebar to launch something.
Hmm?
And so Epic actually has something exactly the same. It's like control space, I believe. If you're in a patient's chart, there are probably like 500 activities that you could bring up in a patient's chart,
Yeah.
and you can kind of hotkey search for them without having to make a shortcut for it.
Oh, wow. Interesting.
Yeah.
Most frustrating thing about hospital tech today?
Um, I think that vendor lock-in piece
Yeah.
is kind of a drag, to be honest. I think there are other ways that hospital technology just hasn't kept up with what we expect from modern interfaces. I have a blog that maybe I'll get out sometime soon, but like when we were in the in basket, typing what are essentially like email messages, right? There is no autosave. And when you need to start like a
Oh,
reply to a message,
yeah.
it basically creates a new window that hides the previous window. And so you lose all that context and formatting. How long has Gmail had autosave for? Like 15 years or 20 years or something. And
Right.
so that's an obvious problem. But again, getting back to like, does it ping people enough? I don't know.
Right.
Maybe if I blog about it, rally the troops, but there's
Yeah.
just so many other things to solve.
What's your favorite band right now?
I it's always hard for me to pick out a specific artist. But I will say I've been listening to a lot of jazz rap lately. I go through kind of cycles, especially when I'm like coding or reading.
Yeah.
I was into like classical for a while, but jazz rap is a nice blend of like uh exactly what it sounds
Jazz
like.
and
And so
rap.
that's my coding music right now is Spotify jazz rap.
Very nice. Coding music is important.
Yeah, yeah, yeah.
If you weren't doing any of this, medicine, informatics, software, what would you be doing?
This one's kind of a cheat because I really swear I'm an engineer at heart. But I have this not so secret retirement dream of becoming an internet service provider. I don't know if you read Ars Technica at all, but like every year and a half, there's a story of some guy that lives in rural peninsular Michigan or something that basically trenched his own fiber for him and his 200
Yeah.
neighbors.
Yeah.
And that's like the blend of networking technology or technology in general and nature together in that way is so cool to me. And so I would become my own rural internet service provider if I weren't doing all of this, which is still technology.
I thought you were going to say you were going to start a jazz rap band or something. Something completely unrelated. Great. Thank you very much.
Yeah, thanks so much, man.
Yeah.
All right, see you, man.